Hi everyone. So today we will solve this problem container with most water. In this we are provided with the array named height and each number in the array represents the height of a line and the distance between two lines is 1. Okay, so if you see in this diagram, this array represents this diagram. So if you see first line is 1, then the second line is 8, then the third line is 6 and so on. And the distance between line number 1 and line number 2 is 1, distance between line number 2 and 3 is 1 and so on. So we have to find the maximum amount of water which can be stored among any two lines. So let's say that we take line number 1 and line number 2. What is the water it can contain? It will contain water till the level of line number 1, correct? Because if we try to fill more water in this area, it will spill out. Okay, that's why it will contain water till this level, right? So if we see in the example, the maximum water contained is between line number 2 and line number last one. So how do we find what is the water contained? So we will find the distance between both the lines, which is 7, 1, 2, 3, 4, 5, 6, 7. And out of both of them, obviously we can fill water till the height of the line, which is minimum out of both of them. Okay. So the minimum out of both is 7, which is this. So 7 multiplied by 7, which is 49. We cannot consider any other line because any other value which we consider will be smaller than 49. So this is what the problem is. Let's see how we can solve this using two-pointer approach. Let's solve this using two-pointer approach. So here, this is our array and we have represented it in this graph format. Okay. So here what we will do is the first step is to assign left and the right pointer to the leftmost and the rightmost element. So here we will have left, then we will have right. Then first of all, we will find the amount of water this left line and the right line can contain. To do so, what we have to do is find the distance between R and L, so which will be 7 minus 1 multiplied by what is the minimum out of L and R, which is 1. So it will be 6. Why we are taking the minimum? Because the amount of water which two lines can store will be defined by what line has the smaller value. Because if you see, if I try to store water, it will only store till this level. Even if I try to pour more water, it will always fill out. Okay, so that's why this smaller value will define what is the amount of water lines can store. Okay, so now what we have to do is after this, we have to move either left or right pointer towards center. But the decision which we have to make is which pointer to move. Let's assume we move left pointer to the center. So now the new water, these two lines L and R will contain is R minus L, 7 minus 2 multiplied by what is the smallest between both of them, 8 and 1. It is 1, it is 5. So if you see the amount of water which we stored earlier is now small. But why this happened? Okay, so the observation, if you see, it doesn't matter what is the length of the other line is. If this R remains 1, it will never store more water because the bottleneck is the smaller line. Okay, so in this question, what we have to basically do is we have to try to increase the value of the bottleneck length. So the bottleneck length is the smallest length out of L and R. That's why instead of moving left towards the center, we will move right towards the center. So the simple thing is we will compare L and R and whatever is smaller, we will move toward the center. Now if we try to find the value of the water it can contain, so the distance between L and R is 6 minus 1 multiplied by what is the smaller among L and R? Both are same, so we can take 3. This is 15. So now 15 is the new max. Now L and R both are same. In this case, either we can move L to the center or R to the center. Okay, so let's assume that we will always move L to the center whenever left and the right pointer have the same value. We have moved L to the center. Now, what is the new value of water which these two can contain? Distance between both of them is 6 minus 2. And out of both of them, the line which is smaller is 3. So 3. So it will become 12. So this is smaller than 15. So this remains the new max. Okay. Now we will compare L and R. So L is 8, R is 3. So we will move R towards the center. So R will come over here. And now the water they both can contain is 5 minus 2 multiplied by, both have the same value 8, which is 24. So this is the new max now. Okay. Again, both of them have the same value. So we can move L to our right. And then again, we will compare the water value. And then if it is more than the 24, we will store it. But it won't be the case, because if you see from 2 and 5, the amount of water they can contain is this, till this level. These two towers cannot contain more water. Their level is always smaller than this one. Okay, so even if we proceed further, the values which we will get will always be smaller than 24. All right. So this is how we can solve this problem using two-pointer approach. So the complexity is simply big of n. If you see, we are simply traversing the array from left and from the right also. And the simple thing is, we will move the pointer which has the smaller value towards the center. That is the main idea here. So let's code this solution. It is pretty straightforward. So this is the code. Here we have two pointers, left and the right pointer. Left will contain value 0, right will contain the rightmost index of array height. Then we have this variable water, which will store the maximum water which we have stored till now. So it will be 0 initially. Then we will have a while loop where the condition is left is smaller than right, because left and right both cannot point to the same line, because even if they suppose point to the same line, it will not contain any water. We need two lines to store water. So that's why left will be smaller than right. Then in this line, we are calculating the amount of water, the max amount of water which we can store till now. So this water values is some previous value which we might have stored earlier. Okay, so we might have taken two lines some time back, and we would have found some value that this is the amount of water we can store. And this is, we are calculating the current water which we can store using left and the right line. So to do this, what we have to do, we have to find the distance between both of them, which is right minus left. And we have to multiply with the minimum height between left or right. Okay. So once this is done, we will get some value, which is the amount of water currently we can store. And then we will then we will compare it with the previous water value which we have stored. And we will get maximum out of both of them, which will be stored in the water, this variable. So now these pointers left and right needs to be moved towards center. So which one of them should we move? That will depend upon the height. So we will compare the height of left and right. If the height of right is smaller, so we will move it toward the center. And in other cases, we will move left towards the center. After this loop is done, we will get the final answer in this variable water. This is what we will return. And if you see, the simple complexity is big of n, because we are simply traversing the height array using left and the right pointer. This is the code. I will share the link to this code, and you can try it yourself. Thanks everyone for watching this video. Bye.